So let's move on to number three and four. All right, so number three, we're going to look at the transformation. I'll quickly give you a sketch of what it would go to and what it would look like. And then I will let you use those skills as far as how did we find the X-intercept and Y-intercept, and then how we could do it by hand, okay? So let's go ahead and identify the pieces. So BCAD order says we're going to do all horizontal change first, and then anything out in front, like multiplied by a negative number, or anything on top, and anything to the right is all going to be vertical change. So this negative over here, this 3, and plus 0, nothing happened over there, is vertical change. And then these denominators. The denominators only are the horizontal changes. Okay, here we go. Let's go ahead and list them out. So the first one is a horizontal shift because it's addition, 1 unit to the left because we do the opposite. Okay, so now I'm going to look at this number 2 right here. This number 2 could also have been written as 2 times 1 over x plus 1 plus 2. So you could have had this 2 right here out in front, and it means the same as it's written right here. Okay, this is still a vertical stretch, whether you see it here up front or on top as the numerator. Now understand that because this is the same as 2 over 1. So our second one is going to be a vertical shift, and it's going to be by a factor of 2. And then our third and final one is going to be this piece right here that is going to show that we are vertically shifting. So vertical shift. Oh, I just realized what I did. It's not a vertical shift. It's a vertical stretch by a factor of 2. The vertical shift is going to be 2 units up because you follow the rule with the y. Okay, so let's come over here and do all the transformations in one shot. So I go to the denominator. It's going to be horizontal. It's adding or subtracting, so it's going to be a shift. And it's 1 unit to the right because we do the opposite. Then I look at this negative. So it's going to be a vertical reflection. So we could just say it reflects across the x-axis. And then 3, okay, 3 is going to be looking at this number 3. And again, it could be out in front of it or it could be in the numerator. This is going to be a vertical because it's not in the denominator. Everything else is vertical. A vertical stretch because it's bigger than 1 by a factor of 3. And then we see that there isn't a shift that's shown here as far as plus a number. So you can always say it's like plus 0. Means it did not shift up or down. So no vertical shift. All right, so let's look at what happened with our horizontal and our vertical asymptotes, and then we can draw a quick sketch. Okay, so here we go. The horizontal change is going to show right here, is going to show where our new vertical asymptote is going to lie. Okay, so it shifted 1 to the left. So at x is equal to a negative 1, that's where our new vertical asymptote will lie. Okay, just like our vertical shift here, 2 units up, is going to show our original horizontal asymptote is now going to shift up by 2. So that our new horizontal asymptote is going to be y equals 2. And our new vertical asymptote is going to be x is equal to a negative 1. And because of the fact there were no reflections, okay, we still will have our graphs somewhere in this quadrant 1 and this quadrant 3, if you will. If you forgot 1, 2, 3, 4, that's how you label the quadrants. So all of this is 1, this is 2, this is 3, and this is 4. But again, that's if and only if our vertical and horizontal asymptotes are here and here. When they shift, then the quadrants, if you will, kind of shift as far as by the graph. So this is all 1, this is all 2, this is all 3, and this right here would be kind of interpreted as all 4. Just quick references so that you can quick sketch these things. So for the sake of time, I'm not going to go through and show you all the steps to get the X and Y-intercept and how to transform all of these points. But notice that the way we did over here, you're going to do both these steps to get the X and Y-intercepts and also these steps to actually transform them if you're doing this by hand. Okay? And when you do that, the graph approximately looks like, and I'm just going to do a quick sketch. Here is the X-intercept at -2, 0. And then the Y-intercept becomes 1, 2, 3, 4. And then the graph looks something like our new graph here. Okay. So let's come over here and do the same. The most important thing, again, are these vertical asymptotes, this vertical asymptote and the horizontal asymptote. So horizontal shift 1 unit to the right is going to have a new vertical asymptote at x is equal to 1. So vertical asymptote at x is equal to 1. And then importantly, this was never shown to have a shift. So because it never shifted up or down, our original horizontal asymptote remains intact. Okay, so the horizontal asymptote is going to remain at y is equal to 0. Okay, and if I were to graph these and do sketches, I could see what they would look like. I'll just do it just real quick for practice. If I want to know what the y-intercept is, well then plug in x is equal to 0. So in my original equation, I'm going to put 0 right here where x is at. So it'll be 3 over -1 is a -3, but then times this negative becomes a +3. Okay, so at this would be at 0, +3, or y is equal to 3, which is going to be right here. And that's the piece that if I were to graph more points, I'd get something that looks like this. Okay? Because it did reflect. This piece down here that used to be in quadrant 3 reflected across the x-axis and ended up going to quadrant 2 right here. Okay? So that's what's happening as far as the transformation is concerned. Okay, so now let's go to find the x-intercept just real quick. That's plugging in 0 for y. So if I did that on my original equation, that's putting it right here is 0. So it's 0 is equal to all of this -3 over x minus 1. And now we just got to find x. When we find x, we'll know over here our x-intercept that we can write in. Okay, so if I multiply both sides by x minus 1, like we did before on that other example, notice that this zeroes out and I get -3. Well, this isn't a true statement. So this is not true. Therefore, there will be no x-intercept. There's none. Which makes sense because if we were to plot more points, our points would look somewhere like sketched out right here. But you notice it never crosses the x-axis. Here was my original x-axis, which remains intact as my horizontal asymptote, means I'm not going to touch it. But over here, I do have a y-intercept on my y-axis because of the fact that my vertical asymptote moved. And when it moves, you will have a y-intercept. Just like when the horizontal moves, then you will have an x-intercept. Okay, so a couple more pages for our notes, just quick identifications. For the following graphs, write a possible equation for the parent function. Okay, so let me show you. Your first goal is to find the center. Where is 0, 0? So 0, 0 looks here, and 0, 0 looks here. This is the original center, and I'm talking about the original parent function of 1 over x. So this was shifted. It looks like 1, 2, 3, 4, 5 to the left. Okay, so we're going to say a horizontal shift 5 units to the left. and then it looks like it was shifted 2 units down. So a vertical shift 2 units down. So immediately I can say my equation is going to be 1 over x plus 5, because it's the opposite with horizontal, and then minus 2 because you follow the rule. So we're going to say g of x is equal to this. Since our original function was f of x, transformations, just like all year, are going to be g of x. Okay? G of x is the new graph, if you will. Okay? So this graph right here of what we have is exactly the transformation. Notice that we are still in quadrants 1, if you will, and 3, so there weren't any reflections of some sort. And our key points still remain intact, almost like 1, 1, and -1, -1, and that's referenced to this new center. Okay? So all this shifting showed that no transformations that were stretches or compressions existed. Okay, so the new vertical asymptote is going to be at x is equal to -5, and the new horizontal asymptote is going to be at y is equal to a -2. Let's do this over here. I shifted 1, 2, I shifted 1, 2, 3 to the right. Okay, so 3 to the right means my new vertical asymptote is x is equal to 3. And then I went 1, 2 up. So y is equal to 2 is my new horizontal asymptote. Okay. Now I still have this parent function as starting off at 1 over x, and my new function is going to be g of x is equal to, well, since I shifted 3 to the right, it's going to be x minus 3. And since I shifted 2 up, it's going to be plus 2. Again, horizontal is opposite. The vertical is follow the rule. And this is what it would look like, okay? And because there were no stretches or compressions, we still have our 1, 1 and -1, -1 kind of representation over its new origin or its new center, if you will, okay? When I say 1, -1, I mean just up 1, over 1, or down 1, left 1, okay? Or however you want to look at it, it's just one away from each other as far as showing that there aren't any vertical stretches or compressions or horizontal stretches or compressions. Okay, so this would be a good equation to show the transformation for this particular one here. And our last slide. Given the following attributes, write an equation that you can see. So we want the domain is not equal to 5. Okay, so the domain is not equal to 5 means that my vertical asymptote is x equals 5. Okay? So if x is equal to 5, I want you to imagine this graph that's right here already, that this is 0, 0. This is the origin. This is our default parent function. Okay? So what's in gray right now is going to be f of x is 1 over x. And we want to shift 5 units to the right. So 1, 2, 3, 4, 5. Here's our vertical asymptote of what we just wrote down. And then it says the range is not 2. So if the range cannot be 2, if a y value cannot be 2, then that's where the horizontal exists. Okay? At y is equal to 2. So we have y is equal to 2 as our horizontal asymptote. So y equals 2, x equals 5. And that's what we know from the domain and range of what it could not equal. So this 0, 0 becomes way over here what looks like at a new center of 5, 2, if you will. Now, I'm not going to put 5, 2 like this because a point doesn't actually exist there. But if one did, that's what it would be. It would be at 5, 2. Okay, and then we did not have any vertical stretches or compressions that were mentioned. So we can say that up 1 over 1, left 1, down 1 would be our new key points, if you will, that we could just draw graphs that look like this and draw graphs that look, pieces of the graph that look like this. Okay, so our g of x is our transformation. It shifted 5 to the right, so it's x minus 5, and it shifted 2 units up. So it'd be plus 2. Okay, so up here, just to finish it off, y is not equal to 3. That means y has to be 3 for my new horizontal 1, 2, 3 horizontal asymptote. Okay, and it says x is not equal to negative 2. That means the vertical asymptote is that x is equal to a negative 2. Okay, and that's going to be right here. So therefore, the equation is going to be, it got shifted to the left. So it's going to be x plus 2, because it's the opposite. And it got shifted 3 units up, and it would be plus 3, just like that. Again, no stretches, no compressions, no reflections. So from the center, from my new center, if you will, I'm going to highlight it in gray, my new center, I'm going to go up 1 over 1, down 1, left 1, and that will be where the graphs would exist. Okay, and that's it for the transformations as far as dealing with horizontal, vertical asymptotes, domain, range, X-intercepts, Y-intercepts, and all the transformations the way we would list in between.